Hello everyone. Today we'll discuss the concept of air mass and fronts. I am Bhumika Saini. I have done my engineering from NIT Jaipur. You can follow me on Unacademy by following this link. Unacademy courses are free of cost, but if you like the course, you can pay an optional fee by following the contribute link on Unacademy. Now, what are air mass? Air mass is an extremely large body of air where the properties of temperature, moisture, and other physical properties like density, etc., these are fairly similar in each of the horizontal layer at any given altitude. So, these are extremely large body of air having similar properties, right? These can cover hundreds of thousands of squares of miles, right? And these air mass, they acquire the properties of source regions, right? So source regions are simply geographic areas where an air mass originates, right? So the longer the air mass stays over the source region, the more likely it will acquire the properties of the source region. So this is the definition of air mass and how it acquires the properties of source region, right? Now the size and dimension. So it extends till tropopause. Width is hundreds of kilometers. Height may vary between 8 to 12 kilometer. That is like it extends till tropopause. The latitudinal extent may vary from 3,000 to 6,000 kilometer. Right. So that's why these are extremely large body of air. Right. Then what are the conditions for origin of air mass? So first of all, how this air mass will form? These are the different conditions. For example, there should be homogeneous surface. It should be either land or sea. It should not be the margin of land and sea, right? There should be isotropic surface. That means less of topographical variability, right? There should be lack of turbulence in air, lack of convection in air. Generally, there should be atmospheric stability, right? So these are the conditions for origin of air mass. Then only it will acquire the properties of source region, right? So let's discuss about the different types of air mass, right? So classification of air mass can be done on the basis of nature of surface, source region, temperature, atmospheric conditions, right? So on the basis of nature of surface, it can be classified into continental or marine. I told you they will be formed either over the land or sea, not on the margins, right? So either continental air mass or marine air mass. Source region, either it will be polar or tropical. Temperature, it can be a cold air mass or warm air mass depending on the type of source region, right? Atmospheric conditions, it can be a stable air mass or it can be an unstable air mass. So this is how we classify air mass, right? So four general air mass classification categorized according to source region. Polar, located polewards 60-degree north and south, right? Tropical, then located within 25 degrees of the equator. Continental, located over large land masses, they are dry air mass. Marine, these are located over oceans and these are moist. So then there are different combinations of air mass you can make, like continental polar cold air mass, that is dry and it is stable, right? Then continental tropical air mass, that is hot, dry, stable, right? Then marine polar, that is marine polar, that is cool, moist and unstable, right? Then maritime tropical, it is warm, moist and usually unstable, right? So these are different combinations of air mass which you can make. So just the gist of all the characteristics of different air mass, like continental arctic, it will be very cold, it will be dry, stable throughout, and tropopause height, that is very low. Maritime arctic, it will be cold, moist, unstable in lower levels and height will be low. Continental polar, it is cold, it is dry, it is stable throughout and the height is low. Maritime polar, it is cool, right? It's not cold, it's cool. It's moist because it is maritime, unstable and the height will be medium. Then maritime tropical, it will be hot. Why? Because it's tropical. Then moist. Why? Because it's maritime. Very unstable and height will be high. Continental tropical, very hot, dry because it is continental, very unstable and the height will be very high. So these are the different features of different air mass. You can see it here. These are continental polar, continental arctic, maritime polar, maritime tropical, right? So these are continental tropical. These are different air mass, right? And the characteristics we have already studied in this particular table, right? So now let's discuss about fronts, right? Now, what is front? Front is the transition zone between different air mass with distinctly different properties, right? So we have already studied air mass. Now, if two air mass with distinct different properties are there, so the transition zone between them is known as front, right? So when large mass of warm air and cold air they meet, they do not mix. Instead, they form a front, right? And this front may extend up to hundreds of miles, right? And when a front passes, there are weather changes. Okay, so let's discuss the types of front. Now, fronts can be classified into cold front, warm front, occluded front, stationary front. Right. So we'll be discussing all these four fronts in the in the next few slides. Now, what is cold front? A front in which cold air is replacing warm air at the surface. You can see it here. This is the cold air mass. This is active. Right. It will replace the warm air mass. So warm air mass is uplifting, and cold air mass is encroaching here, right? So you can see the direction. This is cold air mass. So what are the characteristics? The slope is 1 is to 100. Cold, this front tends to move faster than all other types of front, so the speed here is high. It is associated with most violent weather among all types of front, right? And it tends to move farthest while maintaining their intensity. So this is about cold front. Then the weather conditions associated with cold front, generally cirrus clouds ahead of the front, and strong thunderstorms associated with cumulonimbus clouds will be found along the front, right? And a broad area of clouds immediately behind the front. So this will bring cooler weather, clear skies, and a sharp change in wind direction, right? So they are most violent, like they bring most violent weather changes among all types of front, and they are more active. The speed is also high. In case of warm front, here warm air replaces cooler air at the surface, so warm air mass is gradually uplifting here, right? This is the direction. So warm air mass is replacing the cooler air at the surface. Now, what are the characteristics? The slope is more gentle. See, in the cold front it was 1 is to 100. Here in the warm front it is 1 is to 200. That is, it is more gentle than cold front. These move slowly. I told you, cold fronts, they are moving at a fast pace. So warm fronts, these are less violent than cold fronts, right? These are more likely associated with large regions of gentle ascent, because the warm air mass is gradually, here the warm air mass is gradually uplifting, right? So warm fronts, these are preceded by cirrus clouds, then altostratus, altocumulus, then stratus, and possibly fog. See, generally they will be associated with drizzle and rainfall, but in case of cold fronts, they are associated with thunderstorms and cumulonimbus clouds, right? So behind the warm fronts, skies are relatively clear. These are associated with frontal inversion also. Why? Because warm air is overrunning cool air. So warm air is overrunning cool air, so that leads to frontal inversion. Now let's discuss the third type, that is stationary front. Now this front does not move or barely moves. See, here we have warm air mass, and here we have cold air mass. So as such, hardly any air mass is moving, right? This whole front doesn't move, or it hardly moves. So it behaves like warm front, but these fronts are more quiet, right? So here generally the winds on both sides of this front are parallel, right? And typically these are formed when polar air mass are modified so as to lose their character, right? So these are the characteristics of stationary front. Now let's discuss the fourth type, that is occluded front. Now what happens? Because the cold front move faster than warm front, the cold air mass is moving faster than the warm air mass. So what happens? They can catch up to and overtake their related warm front, right? So what is happening? See, here the lower layers will be fully occupied by cold air mass, and the upper layers, this warm air mass is getting uplifted, and the upper layer will be occupied by warm air mass, right? So when this condition happens, that is known as occluded front. So cold air mass below and warm air mass on the upper layers. So these are indicative of mature storm systems. So that is those about to dissipate. These are generally found at the last stage of this front cycle, right? So weather ahead of cold occlusion is similar to that of warm front, right? While that along and behind the cold occlusion is similar to that of cold front. So this is about your occluded front, right? So in today's lesson we have discussed air mass, the different classification of air mass, fronts, what are fronts, the different types of front, cold front, warm front, occluded front, and stationary front. Thank you.